So we are looking at derivative of logarithmic functions to differentiate logarithmic functions. Okay, and this call for the use of implicit differentiations. So let's see how we can differentiate this function. Dx of logarithm log to base b. This is an integer, positive integer. So this is going to be what? Very simple, going to be 1 over what we have here, ln of the what? Of that base. Okay, and we are going to prove that. Let's quickly prove that. Okay, let's prove that. Let's the function, let's call it y. Let's be equal to what? Let's call that function y. Then apply your normal logarithm. So that will be x will be equal to what? B to power what? To power y. If you apply your normal logarithm, don't forget that if you have log to base b of this function equal to y, this one will come to the top of this, and that will be by, and this one will come here, and that will work. That's what I've done here. Then you now differentiate implicitly with respect to x. So this will be 1, and this one is a constant. This is what I've said. B is a constant. If you differentiate this one, it's going to give you b base ln b, just like you have 2y. Want to differentiate it? Let's say you have 2x. Okay, if the s of this will give you what? Will give you this ln 2. Okay, so the same thing also for this case. And don't forget, this is implicit differentiation dy dx. And then you're going to make this dy the subject, and then we have dy dx is equal to 1 over by ln b. Okay, so your dy dx, your y prime is okay. So on the final note, your dy dx is equal to 1 over your b to power y is as its own equation. So that's what? That's x ln what? Ln b. So we've proved that. Okay. So that's just that on the line of logarithm to a constant base. Okay. If the b is equal to e, okay, then we can come back here. Our dy dx will be equal to 1 over x ln e. And don't forget ln of e, okay, natural logarithm of exponential is 1. So that will give us what? 1 over what? 1 over x. So that's the derivative of logarithm of x to base e. That's 1 over x. Okay. Differentiate y equal to natural logarithm of s cubed plus 1. This is a chain rule. So it's going to be the derivative, the y dx. It's going to be when you are differentiating natural logarithm. So it's going to be 1 over the function times d dx of the composite function. The inner function, x cubed plus 1. And that will give you, the derivative of this one will give you 3s cubed all over s cubed plus 1. We have find d dx ln of x plus 1 all over square root x minus 2. So the first thing we do is to apply logarithm for the ln function of the quotient function, and that will be equal to d dx of this will be ln of the numerator. Since it's a division, that will be minus ln of the denominator. That's the first thing to do, to apply the rules of logarithm for the quotient function. Then the next thing to do is to begin to differentiate. But before that, we must know that the derivative of difference of function is going to be the derivative of each of those functions. And don't forget this particular one here, this ln, you can write it as x minus 2 to power half. This half can come to the front. So we now have the derivative of this one will be 1 over the inner function, x plus 1 times what? Derivative of that function times 1. Then minus this one, we have half times derivative of the logarithm function. So that'll be 1 over x minus 2 times derivative of that inner function, which is 1. And that will be equal to 1 over x plus 1 minus 1 over 2 into bracket x minus 2. So we can do the algebra. So if you do the algebra, it's going to give you 2 into bracket x plus 1 times x minus 2. You can cross multiply this one times this one. That's 2 times x minus 2. Then this one times this one. So we can expand the numerator, and that will be 2x minus 4. And this one will be minus x minus 1. We have s minus 5, minus 4, minus 1, all over what? The denominator. We can also solve it in another way. We can solve it in this way also. And that will be, since it's a logarithm function, so that will be 1 over the composite function, x plus 1 all over this one, times derivative of the composite function. So, and this one we call for quotient rule, because this is a quotient function, all over x plus 1. Apply your quotient rule for this one. If you square this one, you have x minus 2. This denominator times derivative of the numerator, which is 1, minus the numerator, x plus 1, times derivative of the denominator. Then open your brackets. So that will be x minus 2. This one will give us this. So we're going to have what we have here, and then multiply this one here, like this denominator. That's 2 times square root of x minus 2 times this one. So that will give you 3 into bracket x minus 2. Do the same thing also for this, for everything here. That will be minus x plus 1 all over 2 times square root of x minus 2, and then times 1 over x minus 2. So that will be this over x plus 1 times, if you open this one, that will be this one times this one, that's 2x. 2 times minus 2, minus 4. This will be minus x minus 1. So you're having now 2x minus x, that's x, and minus 4, minus 1, minus 5, all over this. This one and this one cancel. So our answer is what? Is this. So that's that on this question. Please don't forget to click on the watermarks on the video and subscribe. Don't stop there. Click on like button and begin to type your comments. Okay. Finally, share the links of this video on all your social media platform. Thank you for doing that.